Yes, good morning, students. So let us have a discussion today about this quadrature amplitude modulation. Okay. So this will be the last topic of your module 3. Just let me say what is quadrature amplitude modulation. Okay, that we are discussing MRA QAM. Okay, and this is one of the most widely used hybrid modulation technique. It is basically in 4G standard. Okay, LTE QAM is very much used. Okay, just I said this about yesterday already. Based on the data rate requirement, we have different modulation order QAMs. Okay, fine. So let me define what is M array quadrature amplitude modulation, right? So we have discussed about M array PSK system, right? M array PSK, that is M array phase shift keying, right? What we used to do there, only we used to vary the phase of the carrier signal, right? Phase of the carrier signal, keeping amplitude and frequency constant, right? So that is why it is known as M array phase shift key. Okay. So in case of this M array quadrature amplitude modulation, here the amplitude and as well as the phase of the carrier, okay, is varied. Okay, that is why it is called a hybrid form of modulation. Okay, because we are going to vary the two parameters of the carrier signal. One is the amplitude and another one is the carrier. Hope you have understood what is QAM by this time. Okay, in what way this quadrature amplitude modulation or M array QAM is different from M array PSK. Okay, hope got this point. In case, I repeat once again, in case of M array PSK system, what happens? The in phase and quadrature components, only the phase of the carrier is varied. Okay, right? The in phase and quadrature components of the modulated signal are interrelated in such a way that what I said, the envelope is remains constant. Means envelope means amplitude remains constant. Only the phase of the carrier is used to vary. Okay, other two parameters kept constant. But in case of quadrature amplitude modulation, what I said, the carrier experiences both amplitude and phase variations. Okay, so that is why it is called a quadrature amplitude modulation. And I said it is known as hybrid form of modulation because two parameters of the carrier is varied. That is why it is called hybrid form of modulation. Is that fine? At least you will be able to define what is QAM. Yes, my dear students.
Yes, sir.
Yes, sir.
Yeah. Yeah, don't think that it is something complicated and you cannot define. At least it should be there in your mind that, okay, so far whatever we have discussed the modulation techniques, only we used to vary one parameter of the carrier signal, right? Either frequency or phase or amplitude. Only these are the three main parameters, right? So any one of these parameters we used to, any one of these parameters of the carrier signal we used to vary according to the message signal. But in case of quadrature amplitude modulation, what I said, we are going to vary the amplitude and as well as the phase of the carrier signal in accordance with the message signal. So that is why it is called quadrature amplitude modulation. And I said it is also known as hybrid form of modulation because of the variation of these two parameters. Okay. So to say about the basis function, this M array QAM is basically a two-dimensional signal So it has two orthogonal passband basis functions, so which we denote mathematically as what? Pi 1 of t, which is equal to root of 2 by t cosine of 2 pi f c t, and another basis function is pi 2 of t, which is equal to root of 2 by t sine of 2 pi f c t. Okay, so cos and sine, they are having a phase shift of what? Between cos and sine. You all know that, right? So these two are signals are the orthogonal signals. Okay, and these two we are using it as a basis functions in the QAM. And to say about the signal constellation diagram, okay, with respect to that, what is the distance between the message points, right? So we denote the distance between the message point as d minimum. Okay, so d suffix min denotes what? The minimum distance between any two message points in the QAM. So the projections of the ith message point on this pi 1 pi 2 axis, because it's a two-dimensional signal, I said, right, will be defined as what? A into d minimum by 2 and ba into d minimum by 2. I think this you will understand when I say what is the expression for a QAM modulated signal. So a and bi, okay, are the amplitudes. Okay, so amplitude of ai into d minimum by 2. A is the amplitude of the in phase component, bi is the amplitude of the quadrature phase component. Okay, so where the value of I can vary from 1 to m, that depends upon the symbols, right? Where m is the number of symbols. Means if I say 4 symbols, then the value of I can take what? 0 to 4, that is 0 to 3, that is 0 0 0 1 1 0 and 1 1, right? If the value of m is 8, then the symbols will be what? 8, that is from 3 zeros to 3 ones, in that sense. Okay, where m is the number of symbols. So the amplitude of in phase and quadrature depends on the number of symbols also, right? And those message points are separated by what distance? This is d minimum is equal to, I can write 2 into square root of e naught, or d minimum by 2 is equal to root of e naught, where e naught is the energy of the signal, right? So yeah, so this is how we express mathematically the QAM modulated signal. Okay, I said what is that e naught with respect to the previous expression is the energy of the message signal, the lowest amplitude. Fine. So the transmitted M-array QAM signal is defined as, here we are taking k as the symbol, right? So sk of t is equal to root of 2 e naught by t. See, a suffix k is there, so that is the amplitude. Okay, cosine of 2 pi fct. Okay, then minus root of 2 e naught by t bk into sine of 2 pi fct, right? So this ak and bk are the amplitudes of the in phase and quadrature phase components. Okay, in phase and quadrature phase components, where the value of k can vary from 0 plus or minus 2 and so on up to m value, right? So here two things are there, square constellation and yesterday I told about that circular constellation. As of now we consider square constellation, and in that how the symbols will change, that is by considering gray bit. You all know gray bit means it changes only one bit change, right? From one word to another word there will be one bit change. Let us try to understand that signal constellation diagram. At least hope you will be able to say what is the expression for QAM modulated signal. So it is not very different. What is there? I have in phase and quadrature phase component, that is cos and sine. For that, along with that, we know the basis function, that is root of 2 by t cosine of 2 pi f ct is one basis function, and another basis function is what? Root of 2 by t sine of 2 pi f ct, right? I said they are orthogonal, cos and sine. For that, what is multiplied here? Root of e naught is the signal representation level, and ak is the amplitude variation of the in phase component, and bk is the variations in the amplitude of the quadrature component. Okay, So as I said here, both amplitude and as well as the phase of the carrier signal is varied according to the message signal. That is why it is called quadrature amplitude modulation. So let us try with the next thing. Okay, so to understand this square constellation of quadrature amplitude modulation, we define, I think here, let me say about that what is a square constellation. Okay, in MRA QAM, I said the constellation of message points depends on the number of possible symbols, that is M, right? So what we consider here is the square constellation for which the number of bits per symbol will be even. Okay, for square constellation, the number of bits per symbol will be even. Okay, means the number of bits per symbol means it may be two even number of bits. Okay, it may be 2 or 4 or 6 or 8, like that. Per symbol, the number of bits is that. Yeah. So even number of bits per symbol is expressed as this one, L is equal to square root of M, where M, I said, is a number of symbols, right? And L is a positive integer value. So with this condition, the M array QAM square constellation can always be viewed as the what? Cartesian product of one dimensional L array PAM constellation diagram with itself. Okay, so let us try to understand what is that L array PAM. Okay, so this is how I get the square matrix. What is a square matrix? Means to identify the coordinates of the message points in the uh, pi1 and pi2 axis. Okay, so AI and BI. AI is the what? Amplitude of in phase component. BI is the amplitude of the quadrature component, right? So which is equal to, we say, it can vary from minus L plus 1 to 1 value to L minus 1 to minus L plus 1 to minus L plus 1. Okay, if I say vertical axis, horizontally, that is from minus L plus 1 comma L minus 1 to L minus 1 comma L minus 1. So we know what is L. L is equal to square root of M. Okay, so if you take the example, then you will be able to construct this matrix. I will come to that. So this is what the generalized uh, way of defining the square matrix. So that will give you the points of coordinates of the message points. Okay, so L, I said, it is square root of M, right, where M is the number of symbols, and I said even the number of symbols for square constellation is even number of bits. Okay, so I will come back to this slide slightly, maybe. Yeah, I think if I go with this, I will come back to this. All the things which I have done in a different way. So let me, yeah, take up this here. I was telling about that L array PM, right? Yeah. So let me take the value of M as 4, right? So means 4 symbols will be there. In each symbol, 2 bits will be there, right? L is equal to square root of M. So square root of 4 is 2, isn't it? So with that, I can write this uh, bits, and they are with the distance of d by 2, right? From here to here, it is d by 2. From here to here, it is d by 2. So that is what it is written. This is horizontally oriented constellation, and this one is the vertically oriented constellation. So as I said, yeah, for both pi1 and pi2 axis, okay, I am explaining with respect to L array PAM it is. Then you will be able to get the understanding of how to construct the M array QAM signal constellation diagram. So what we do here is, so hope with respect to this arrow, you will be able to understand this. So we have to write this in the form of matrix. Okay, so from top down, this arrow indicates multiply these two matrices. Okay, okay, so I think I will show with that multiplication. uh, yeah, so first thing I have written 2 constellations for L array PM, where the value of L is what I said is 4 array PM, right? So vertical and horizontal. Let me say how do we construct the constellation diagram for this. Yeah, yeah. So this is for M array quam. Okay, how do I get this M array quam when M is 16? So when M is 16, what is the value of L? L is equal to square root of M, right? Square root of 16 is how much? It is 4, right? So that is why there are 4 bits per symbol. Okay, in the previous example, I said 4 array PAM. Okay, so here I'm taking M is equal to 16. So let me just say how do I get this signal constellation diagram. So what I have taken here as a first quadrant constellation. First quadrant is what here? Yes, is it possible to say looking at this diagram? First quadrant, second, third, and fourth quadrant. Yes, it is simple to understand. See pi 1 and pi 2, right? This is a pi 1 axis and this one is a pi 2 axis. So this is what the first quadrant, second, third, and fourth quadrant, right? That I hope you are having that idea. So how do I get the first quadrant message points with respect to when the value of M is 16, right? How do I get this 1 1 1 0 4 ones 1 0 1 0 1 0 1 1, right? So what is done here is with respect to this. So 1110, okay, 1110 is multiplied. That is a vertical this one, and 1011 here that is horizontal matrix. Oh, sorry, horizontal means 1110 of this pi 2 axis, right, and 1011 of pi 1 axis of this horizontal constellation is multiplied. So when we multiply that, we will be getting the first quadrant constellation diagram, right? So, okay, able to understand this point? 1110, I said with respect to previous, I said the multiplication of L array PAM with itself will get the Quam constellation. That is why vertical and horizontal constellation of LRA PM is multiplied to get the message points of each quadrant. Okay, so first quadrant I get by multiplying this 1110 with 1011. So that is what is done here. Then the second quadrant, what I get? So 1110 is same. Then 0100. So 0100 is what is this one, right? Horizontal this one. So keeping the vertical constellation 1110 only, I am multiplying with 01 and 00. So to get the second quadrant message points. Okay, to get the third quadrant, so we are shifting it to downward. That is sorry, here. So 0001 is multiplied with 10 and 11. Right? So the third quadrant, as I said, 0001. So 0001 of vertical this one, and then 0100 of this one, third quadrant. Then fourth quadrant, so it will be vertical is same 0001. Then horizontal will be what 1011. Sorry, yeah, 1011. Okay, if you do that, you will be able to get the message points of the fourth quadrant. And you just look at the message in symbols. So there will be only one bit change with respect to the adjacent symbols. So okay, it is a gray encoded symbol. It is okay. Means if you start with this, see 4 ones is there. So there is one bit change with respect to adjacent bit, right? Yes or no? Hello, able to catch this point? Yes, my dear students, I am asking able to understand this. What I said is I have written two LRA PAM signal constellation diagram. So one is horizontal and another one is the vertically oriented constellation. Okay, by the multiplication of these two, we will get the message points of the mRNA quantum signal. Okay, so I think those steps are shown here. Uh, yeah, how do we get this one? Okay, so the four quadrants constituting four array quam is this. Okay, to get the first quadrant constellation, what I said, we use the code words along with the positive parts of pi 2 and pi 1 axis. What is that pi 2 and pi 1 axis? Is I think shown here. Okay, so this is a pi 1 axis and this is a pi 2 axis, right? So this is what is written here, multiplying the positive axis of pi 2 and pi 1, that is 1110 with 1011. I get the first quadrant for message points. That is what is done in as a first step. Okay, 1110 multiplied with 1011. That is it. We say with vertical constellation, top to bottom, we say. With respect to horizontal constellation, we say we move from left to right. Okay. Yes, is this point, is this clear? Left to right. Okay, top to bottom. So vertical constellation is from top to bottom. That is why we say 1110. Horizontal is from left to right. That is a 1011. If I multiply those two, I will be getting the first quadrant message points. So similarly, to get the second quadrant, what we do? Top to bottom, then left to right. That is of the uh, 0 1 1 0 1 0 0 will be of uh, the what horizontal, this one. Okay, first we multiply top to bottom of first this with this, and then second one is what, to get a second quadrant, top to bottom of this, and horizontal of left to right of this one. Okay, similarly to get the third quadrant, we multiply, yeah, this is about the second quadrant. Then third quadrant is what, top to bottom of the negative one, that is from here 00 to 01, then 01 to 00. Okay, we move from this side 01 to 00. The next one is 0001 to 1011 to get the fourth quadrant. So that is what is done here. So 0001 to 1011. If I multiply these two, means column vector and row vector. Okay, to get the fourth quadrant. And looking at this, we will be able to say, yeah. So just I want to say how do we do that is, uh, okay, to develop this signal constellation diagram, we need to keep these things in mind. So same binary sequence is used for both four array PAM constellation, right? So as I said, gray encoding is used here. So which means that as we move from one code word to another, to an adjacent code word, there will be only single bit is changed, right? So this is how we construct the QAMS constellation diagram, right? So we move from one quadrant to the next in the counterclockwise direction. Okay, that is why yesterday I think I shown one animated movement of that signal constellation diagram. So this is how it is started. Okay, I will again show the diagram. I yes, hope you got this point. How do we construct this? Okay, this is all about how do we find the status and all. How many states? Means if it is 4 quam, 2 power 4 is equal to 16. Message symbols we will get. And yeah, with respect to this, I was telling. Okay, of course, here the code words are not written. So you can just map that code words with respect to this diagram. Okay, it is same only. So if I say first, see that is a counterclockwise, no? So 4 zeros, okay, with certain amplitude and phase. Then the next will be of this amplitude, means amplitude variation and phase is also changing. Okay, amplitude and as well as phase is changed. The next one is this. Here also amplitude is changed and phase is also changed. And for this one, amplitude and change in the phase. Okay. So like this, it happens for other three quadrants also. So with respect to this, we say we are varying the amplitude and as well as the phase of the carrier. Yes, is this clear? I'm asking. I think I tried my level best to make you understand with this animation. I hope you should be able to. So since I'm saying counterclockwise now, so next quadrant is third one. So change in amplitude and phase, right? For every this one. Okay. So accordingly, if you look at this one, so you will be able to see only there is a one bit change. Okay, from one code word to another code word. Okay, so just you can have a look that. So first four zeros are there, then this four zeros to this one only one bit is changed, right? That is the first bit is changed from 0 to 1. So next one with respect to this code word, so there is one bit change, that uh, is it so? Is it, can I say like that?
No, sir, there are two bit change, sir. One
Ah,
to two.
correct, right? So if I go sequentially, I cannot, because as I said here, only the adjacent code words are changing with one bit, right? So I think you can have that understanding from this diagram here. Yeah, I will give 2 minutes time. Just try to find out how do I say there is a one bit change. It's a gray code encoded signal. Just think to explain. I said no, it is a square constellation. Okay, here you can find one is the outer square and another is the inner square. I have given an idea, means a clue I have given outer square and inner square. If you see only the outer square adjacent code words, you will be able to find there is only one bit change. Similarly, if you see the inner square code words, adjacent code words, you will be able to say yes, there is only change of only one bit. Hope you got that point. Outer square and inner square, I
Yes.
said. Yes, my dear students, are you able to catch that point? What is outer square with respect to the signal constellation diagram? So hope you are able to see my cursor. So four ones, right? Next adjacent code word is this one, 3110. So here there is a change in only one bit, no? Right? Then again, if you take this one, yes, this is 1100 with respect to 1101. What is the change in bit? Adjacent code word. Yes, is there one bit change?
Yes, sir.
Yes, sir.
Oh. Similarly, from 1101 to 1001. What is change in bit? So 1 to 1 is there, 0 to 0. Here only 1 to 0 is changing, right? Then 1 to 1 is there. Okay, got this point?
Yes,
Yes,
sir.
sir.
Yeah, then 1001 to 0001. So 1 to 1, then 0 to 0, 0 to 0, only 1 to 0, right? So only one bit change is there. Then from then from 0001 to 0101. So 1 to 1 is there. Next 0 to 0, only 0 to 1. This is a change in bit. Next 0 to 0 is there, right? Then from 0101 to 0100. So 1 to 0 is change. Then 0 to 0, 1 to 1, 0 to 0 is there. Okay. Hope you got this idea. Outer square and inner square. Two things I said. So there will be one bit change since it is a gray encoded bit. Okay. So this is your outer square. You just think, you just check with the adjacent code words. There will be one bit change. Okay. From year to year, I said again, even from year to year also. So 0 to 0 is there. Next, 1 to 0 is the change. Then two ones are there, two ones are there. Okay. Yes, got this idea. This is outer square. Then inner square is this. These four bits. four code words. That is 1010, right? Means 0 to 0, 1 to 0 is the change, then next 0 to 0 is there, then 1 to 1 is there, right? That this to this. So 0 to 0, 0 to 0, 0 to 0, 1 to 0 is there. So 1 bit change. Then here 4 zeros to here 0 0 1 0 means first bit 0 0, fine. Then next bit is 0 1, that is the change. Next two bits are 0 0, here also 0 0. Then 0010 to 0011 means first bit is changed, 0 to 1 it is changed. Next three bits are same, 001 001. Sorry, so I said inner square, right? Yeah, 4 zeros to 0010. Okay, one bit change. And how do we get the message points in each of the quadrant? By multiplying the what L array PAM of vertical and horizontal constellation diagram from top to bottom of vertical constellation with the left to right of the horizontal constellation. That is why it is shown here with respect to matrix. Okay, 1 1 1 0 and then 1 0 1 1. If I multiply these two matrices, I get this one. Similarly, the second one, third one, and fourth one. Yes, any questions with respect to writing the signal constellation diagram? Of course, here this empty squares, no, this I wrote with respect by taking mathematical this one, so I could not delete that. So don't misunderstand that. So it is not there. Okay, that is why with respect to from textbook scan copy, I have shown here. Actually, I need to write like this. I could not. Okay. Yes, do you have any doubts with respect to the signal constellation diagram of QAM? And I said mathematically, this is what we say the value of A and BI. What is the value of L also I said. Yes, any questions? No questions. Means not understood. Yes, nobody is having any questions. Shall I proceed?
Sir,
Ah.
how do you take the order, sir? Like you gave two signals with distance d by 2.
Ah.
How do we take it in the order? Like one should be on should be the starting point and 00 should be ending, or is it any given random sequence?
This code word. No, with respect to this L array, we have written a signal constellation diagram. From this, so here, what I have shown here for two orthogonal constellation diagram for 4 array PM I said, right? So what I said here, 1 minute, yeah. Yeah, just have a look here. So the value of L means when an even number of bits per symbol is taken, so L is equal to square root of M, right? Where L is the integer value. So with this, an M array QAM square constellation can be viewed as what? Cartesian product of a one-dimensional L array PAM constellation with itself. Okay. One-dimensional L array PAM constellation with itself. So by writing two L array PAM constellation diagrams, multiplying those two, I will be able to get the signal constellation diagram of M array QAM. Okay, so this is one way of doing it. This is for the square constellation, and even for circular constellation is slightly different. Okay, so that I am not uh,
Yes,
giving
sir.
here. So to get a better idea, you take one example with respect to this one only and try to understand. So that may take little bit amount of time. As of now, I don't say it is a random. Okay, it is not a random. With respect to this, You know how do we get this distance as d by 2, the minimum distance? Okay, we know how to calculate the minimum distance between two symbols.
Yes, sir.
Sir, Mallikarjun sir,
Sir.
can I take about 2 minutes?
Yes, sir. Yes, sir.
Yes. Good morning, students.
Good morning, sir.
Sure.
Sir, recording irla?
Okay. No issue, sir. No issue.
No issues.
So just no, I want to ask how many of you are no, how many of you have entered the data for vaccination Monday? Bhargav Verma. Bhargav Verma is there?
Yes, sir.
You are not taken, no?
No, sir.
So many people have said no, you have not taken. Then what is the problem in taking? When college is making so many
Sir.
attempts, so many efforts they are putting and trying to arrange for vaccination for the students. This is as per the instruction from Vice Chancellor of VTO that all students should be vaccinated by 7th July. Okay, principal is communicating and vice principal is communicating, sharing the seat, and you are not able to write the data. What is the difficulty in at least entering the data? 2 minutes it takes.
Sir, I submitted the status, sir.
Status submitted, but are you willing to take on Monday or when you want to
No,
take?
I was out of state, sir. I was in my home.
At least plan, no? You cannot
Yes,
talk like this. You are engineering student. You need to have plan. You know calendar of events. When your semester starts, when you have exam, when you have second exam, third test, second test, everything you know. Based on that, you have to give the data. See, don't make us forward 10 times the same seat. Hope people understand this. Okay? Teachers are suffering like anything because of you people. 1 or 2 people are just giving the data. 10 people say not taken, but they don't say when they will take it. What is this minimum common sense you people don't have? You are behaving like school kids. This is for you. You decide. If you have taken outside, say I have taken, I don't need your help. But you have to come with this one, vaccinated, taken status only. For any test conducted in future, any lab exam conducted in future, any final exam, you come, you should show the certificate. Otherwise, we will not be able to allow you people. This is coming from the university. It is not me or Mallikarjun sir is interested in. We are not interested in this. We are totally disturbed. See, this is a response. Very bad. Even in the class, I have heard. Many teachers are not getting the response. Why? Very few people answer the questions. You have so many problems. Can I expect at least by today, end of the day, that all will enter the data, and who are willing to take vaccination Monday, please enter immediately, finish it off, so that the second vaccination, this one date you will get early, right? So if you are delayed, second dose will also be delayed. So plan for it. Small things these are. After 1 year you will enter an industry. How you will plan, how you will work in a group of people to execute the project, how you will plan, how you will deliver the product to the customer. These are small things. Don't make us message you again, WhatsApp again, send mails to you people, because vice principal has sent 6 to 7 times reminders to me last 3 days. See the seriousness of the thing, because yesterday they had a meeting with vice chancellor of the university and exams are going to be offline. It is very clear, and you have to decide and enter the data. See, you are not punished here. You are given opportunity. College is taking so much pain. And you tell if you are able to arrange yourself and come for the exam, no problem. Tell that clearly. That by this date I am taking first dose, not college, in this hospital. Tell me that. Is it clear? All of you will fill the data. Niharika,
Yes, respond students.
Yes, sir.
Yes, sir.
engineering students. So this is how we have to address things. We don't have better job now. You people are busy. Respond, yaar. After 1 year, nobody will force you like this. And you will say this, no, engineering education was far better than the company work. Okay. You will regret later. Enjoy it. Respond to the teacher. They will be happy. They will be motivated. That is how it should work. Teacher and student, they should go hand in hand. You discuss your problems. You discuss your no, ideas. Respond to the queries. Respond to the no, things that higher ups wants. So that we can help you better. We can work for you people. We are ready to help. Okay. What are the queries? Which industry you want to connect? Which core area you are preparing? Tell us. We'll try to connect to the expert. That way you help. But these small things, no, don't kill teachers' time. Thank you, sir. So
Fine, sir.
after the class, make sure that all enter the data appropriately. And Monday drive, try to take part in it. Maximum. I want maximum from 6M. You should give an example to juniors. Okay. So I don't want to discourage you. You people are no, smart people. You are capable of doing a lot of things. Only that drive is required. Okay. Okay then. Please update that. Thank you, sir. Thank you.
Fine, sir. Fine, sir. Yeah, with respect to writing the signal constellation diagram of this 4-array PAM, no? So what I said is, see this horizontal constellation diagram. So there will be, I said, change in only one bit, right? So take, if you say it is 0, 1, so with the next bit, there is a change of only one bit, right? So 1 to 0 is changed, and next bit is 0, 0 is same is there, right? The next 0, 0 to 1, 0, right? So this 0 is same, then next bit is changed from 0 to 1. Next 1, 0 to 1, 1. So 0 to 1 is changed, so next bit 1 is same. So this is what the gray code is, right? So this is horizontal constellation, and this one is the vertical constellation diagram for LRA PAM. That is when L is the value of L is 4, right? So if you go here also, even either you can go move from top to bottom or bottom to top also. So just look at this 1, 1 to 1, 0. There is only one bit change, right? So first bit is 1. So here also 1 it is. Then 1 to 0 is changed, right? Then 1, 0 to 0, 0. That is first bit 0, 0 is same. Next bit 1 to 0 is changed. Then 0, 0 to 0, 1. So first bit is changed from 0 to 1, and next bit is same. Okay. So just multiplication of these two yields the M-array QAM signal constellation diagram. Okay. So just you can move this to the center point. Then what I said, 1, 1, 1, 0 is the vertical matrix multiplied with horizontal matrix of what? 1, 0, 1, 1. Right? So that you will get the first quadrant. Let us assume that this is there at this point vertically, right? Then multiplication of these two with these two yields first quadrant message points, right? Similarly, the multiplication of this with respect to this yields the second quadrant message points. Then the multiplication of this with respect to this yields the message points of the third quadrant. Then multiplication of this and the multiplication of this one yields the message points of the fourth quadrant. Okay. Hope this point is clear. Hello. Yes, my dear students, please respond. Is this
Yes.
clear?
Yes, sir.
So very simple to understand. Only thing is you have to give some time and attention. Otherwise, it becomes very complicated. Hmm? Why I start with 0, 0, 1, 0 and all? You need to scratch your head like anything. So first you write the horizontal constellation diagram. Okay. Then the vertical means if you, I think if I what I can say, if I make this vertical constellation diagram to be horizontal, just see how it will be. Same, no? It starts means this will come here, then next this one, 1, 0, then 0, 0, then 0, 1, right? So two things, just multiplication of these two yields the MRA quam signal constellation. Hope this is all very simple to understand. I hope you have understood how you can write that. And so yeah. Yeah. So just I will highlight this point. The important point to note here is that all the code words obey the gray encoding rule, not only within each quadrant, but also as we move from one quadrant to the next one. Okay, I think that you can check. So within this quadrant, just check with this bit to this bit, this code word to this code word. Is there only change in one bit? 1 to 1, then 1 to 1, 1 to 0 is a change, 1 to 1 is there, right? Isn't it?
Yes, sir.
Then 0 to 0, 1 to 1, 1 to 0 is the change, then 1 to 1. So this is in first quadrant. Similarly, the second quadrant, 0 to 0, 0 to 0, 1 to 0 is the change, 1 to 1. Okay, then next is what? 1 to 1, 0 to 0, same, 1 to 0 is a change, then 1 to 1. With respect to only the second quadrant I'm talking. So there will be change of only one bit in each code word with respect to the adjacent code word in each quadrant also, and even with respect to outer and inner square of this quadrant, this signal constellation diagram. Okay. Fine. So this is about the calculation of average probability of error. Even block diagram is there. As per your text, block diagram he has not given. If necessary, I can give. I think without that also, you should be able to say what is quam. Okay, and even with mathematical expression, how do we express the quam modulated signal? So as we done for defining the bit error rate for QPSK and other things, in the same way, the probability of bit error is also found for this quam. So here, maybe I think in between steps also required. Just to begin with, what I can say, the probability of correct detection. Okay, for MRA quam will be given as what? P suffix C is the probability of correct detection, which is equal to 1 minus P dash E whole square, where P dash E is the what? Probability of the symbol error for LRA PM signal. So here what we say, what is L, and the probability of symbol error P dash E is given by this formula. Okay, P dash E is equal to 2 of 1 minus 1 by root M into Q function it is. 2 of root of 2 E naught by N naught. Then we are going to substitute this value, right? So that is the probability of symbol error is 1 minus PC. So just PC you substitute as equation 1, what I discussed in the previous slide. Then it will be approximated as 2 P dash E. Okay, you can expand this with A minus B whole square formula. Then it will be approximated as 2 into P dash E. So from that, I can say what is P dash E. Okay, so 2 P dash E is there here. So if I multiply that, we will be getting PE, 2 into that of, right? That is what is written 4 of 1 minus 1 by root of M, Q of root of 2 E naught by N naught. Then, so this is the average energy of the MRA quam signal. Okay. And yeah, how it is written here is, so 2 E naught by L, where E naught is the transmitted signal energy, I said. L is the number of amplitude levels, right, of the in phase and quadrature component of this MRA QAM signal. So it varies from 1 to L by 2 of 2I minus 1 whole square. So you will be able to say what is the average energy of the signal. Okay, by approximating, it has been brought to this level, that is 2 of m minus 1 of E naught by 3. Just uh, have a look about how we can simplify and bring it to this one. Okay. Yeah. Finally, we can express the average probability of symbol error in terms of the average signal energy. So that is why it is written in terms of average signal energy. Okay. Okay. So this is all about, because about probability of error, I think it is not gone each and every step of how we used to do it in earlier modulation techniques like either FSK or BPSK. So it is covered in a very light manner. Okay, I think if you understand this much is more than enough, what I feel. So this is all about QAM, what I can say. So this is from your text what I have taken, screenshot of that. Then this is what I have done from my end to make you understand. Okay, at least you try to understand with respect to this animation diagram. Okay, how phase and amplitude varies. Is this fine? This
Yes,
is
sir.
what. Hmm? So you can also think of doing at least this diagram, how you can do. So this is with the circular constellation I said, and this is with the square constellation, square lattice, what we say. So here with respect to m is equal to 4. Okay. You see, then when m equal to 16, this is what we get. When m is equal to 32, this is what the signal constellation diagram is. When m is equal to 64, this is what the signal constellation diagram is. So m is equal to 64. In each quadrant, we will be having 16 message points, right? So 16 into 4 is 64. In case of m is equal to 32, in each quadrant, we will be having 8 message points. So 8 4 is 32. In case of 16, in each quadrant, we will be having 4 message points. That is 4 into 4 is 16. Okay. When it is m is 4, we will be having 1 message point in each quadrant. Okay. Yes, hope you all will be able to get through this. If you have any questions, you can ask. Another 2-3 minutes is there. Yeah, this I was. Yes, with respect to efficiency, what we say with respect to for QAM, 16 for QAM, it is 4 bits per second per hertz. Okay, because 2 power 4 is 16. Okay, then I think I told here how do we do that. With respect to block diagram, I'm saying here we are going to again split the data into 2 channels, that is in phase and quadrature paths, right? So similar to the QPSK only. Okay, even in QPSK also, first task is what? After making the input incoming binary data, encoding with NRZ signaling, then we used to split the data into odd and even, right? So we say in phase and quadrature path. Similarly, here also it is done. Then as with QPSK, so each channel can take 2 phases, right? With the 16 QAM, it accommodates 2 intermediate amplitude levels also. Okay, there the amplitude level of in phase and quadrature path was same, but here the in phase and quadrature path amplitude levels are different. Okay. Okay, so 2 bits are routed to each channel simultaneously. Then 2 bits to each channel are added, then applied to the respective channels modulator. So I removed that block diagram. Actually, I had in the front slide. I think if you understand this much is more than enough what I feel with respect to your syllabus. Okay, let me stop with this.